I started off as a scientist, but I'm a science journalist now. I've worked as an editor and journalist for the last 15 years or so, and I'm here to talk about the role of the mind in physical health. And so I just want to start off by telling you a little story. So next slide, please. This is Bonnie Anderson. She lives in Minnesota and she's here with her partner Don. And in 2005, she slipped over on wet kitchen tiles and she fractured her spine.
Oh, no.
And she was in an awful lot of pain after that, but wasn't getting any better. She told me that she wasn't able to stand up to do the dishes. She wasn't able to play golf. She absolutely loves playing golf. The pain was making it difficult for her to sleep at night. So she took part in a clinical trial of a promising new surgical procedure called vertebroplasty. And this is where surgeons inject medical-grade cement into the broken bone to strengthen it. And a few years ago, this was becoming increasingly popular. Patients were saying that their pain was gone within a few days, they were back to all their normal activities of daily life, and that was true for Bonnie as well. It was wonderful, she told me. It really took care of the pain. What she didn't know when she had that procedure was that the surgery that she received was fake. The surgeons acted out the entire procedure. She never received that injection of cement. She wasn't the only one. There were 131 patients in that trial that she took part in. Overall, the patients' pain and disability scores were almost halved after the procedure, but there was no difference between the ones who got the real surgery and the ones who got the fake surgery. So I just wanted to start with that little story because it just really gets to this topic of the power of the mind over the body. Can the mind heal us? Does it play a role in physical health? And it's, as you're saying, it's an incredibly old topic and it's a really controversial one. It tends to be a really polarised debate, which is one of the things that attracted me to the topic in the first place. So next slide, please. On one side of the debate, you get claims of pretty much the mind as being a miracle cure, as if we can just heal ourselves of anything if we just think positively enough. Often these claims come from alternative therapists. These are a few of the books that you can buy on Amazon if you want to. We've got How to Heal Yourself Instantly from Disease, Depression and Fear, Change Your Mind, Heal Your Body, How to Heal the Sick as a Beginner. There's Mind Over Medicine. This one claims to be based on cold, hard science, but I'll just read you a quote from the author. She says, "We hold within us self-healing superpowers that are more powerful than any surgery and more effective than any chemotherapy." So this very strong claim is being made for the power of the mind. On the other side, next slide please, we have the skeptics. These are often people from conventional science and medicine. These are quotes from academics, either interviews that I've done with different scientists or comment pieces that they've written. They would argue that the very idea of healing thoughts is deluded, dangerous quackery. They would describe it as tooth fairy science, rubbish, oppressive and morally offensive, the idea that the mind might be able to improve our health. Why would actively doing nothing have any active physiologic effect? It doesn't and it shouldn't. So that's just to give you a bit of context for sort of the extreme views and the strength of feeling that this topic tends to arouse. So next slide please. If we go back to Bonnie's story, she had fake surgery and she felt better. This is a classic example of a well-known phenomenon that you've probably heard of called the placebo effect. Often when we receive a medical treatment that we think is effective, we feel better, even if it turns out afterwards that it was fake, there was nothing in it. It's well known across many different kinds of medical conditions and many different kinds of treatments. It's the reason why we test all new drugs against placebo, so that we know that any improvement seen in those patients is down to the drug that's being tested and not down to this more general placebo effect. But the placebo effect itself is often seen as a bit of an illusion. It's been described as a myth, as a failure. My favourite description is the beer goggles of medicine. This idea that there's nothing real there, you're just seeing what you want to see. The argument goes that if you feel better after receiving a fake treatment, then presumably you would have got better anyway. A lot of people do get better with time. Maybe you just think you feel better, or you just say that you're feeling better even if nothing's actually changed. And all of those things can happen. But there's actually decades worth of research now that's showing that actually there's something else going on. So next slide, please. So just to tell you a little bit about that, I want to take you back to a classic study that was done. Placebo researchers call this the moment that the biology of placebo was born. A neuroscientist called John Levine, this was in the 1970s, wondered whether maybe the placebo effect, rather than being all in the mind, this kind of imaginary improvement, he wondered if it was actually working through a biological mechanism. And at the time, chemicals called endorphins had just been discovered that you might have heard of. These natural feel-good chemicals produced by the brain. They ease pain by blocking pain-related activity in the brain. Some of the painkillers we take, things like morphine, work by mimicking these endorphins. So the drug binds to the same receptor as the endorphin in the brain cell. That's how the painkiller works. Levine wondered whether taking placebos might somehow be triggering this same pathway. So he did an experiment. Next slide, please. On patients recovering from surgery in hospital. So they were in pain. He gave them an intravenous infusion of saline, salt water, but he told them that it was the painkiller morphine. And after that, the reports of their pain reduced. They said they were in significantly less pain. So that's a classic placebo effect for you. They thought it was morphine, there was nothing in it, but their pain went down anyway. It was what Levine did next that was really interesting. He gave them a hidden infusion, so they didn't know that anything was going into their system, of a drug called naloxone. And naloxone blocks those endorphin receptors. It blocks the activity of painkillers like morphine. It also blocks the placebo effect. Even though these patients had no idea that anything went into their system, suddenly their pain went back up. And so it suggested that actually placebos were working in exactly the same way. They were triggering the release of endorphins in the brain. The placebo was working in just the same way as the actual drug was. And this was really the first study that changed the placebo effect from being some kind of vague illusion into a real physical effect that we can study. Next slide, please. So research on that has continued. There have been lots of studies since then confirming that effect and showing that when we respond to placebo painkillers, there's also a reduction of pain-related brain activity, also reduced activity in the spinal cord as well. And one of the main top placebo researchers in the world now is this guy, Fabrizio Benedetti. He's a neuroscientist in Italy. And he has shown that we get these biological placebo effects, not just when we take placebos, but when we take real drugs as well. So in trials, between 1/3 and 2/3 of the pain relief you feel when you take a real painkiller is not down to the direct sort of biochemical activity of that drug. It's down to your belief in that drug. It's down to the placebo effect. When you give people painkillers and they don't know they're getting them, they are much less effective. He has found that a lot of very commonly taken drugs, things like Prozac, Valium, for example, they don't work at all unless you know that you're taking them. Just click again, please. Oh. Can we just get back to that? That's fine. Oh, let me go backwards now.
Everyone close your eyes. Hold on.
Stop.
There we go.
Yeah, there we go, great. He's also shown that there isn't just one placebo effect, there are many. So I've talked about one biological mechanism triggering the release of endorphins in the brain, but for different conditions you can get different mechanisms. So Parkinson's disease, for example, patients have problems with movement because of a lack of the neurotransmitter dopamine in the brain. Benedetti and other neuroscientists have shown that when Parkinson's patients respond to placebo, there is a flood of dopamine in their brain, just as when they take their real drug. A third example, next slide please, that Benedetti's studying is altitude sickness. He's set up this lab 3,500 metres above sea level in the Alps. That's me when I went to visit. Next slide please. So this is the view out of the window. Just want you to see how high up on your motor it is. You have to take 3 separate cable cars up from the nearest ski resort. And this is David, one of Benedetti's volunteers. So he's working out on the stepper. He's breathing supplementary oxygen, or he thinks he is. that canister is empty. He's actually breathing fake or placebo oxygen. And Benedetti has shown that when people get this placebo oxygen, so it's just their belief essentially that they're getting this extra oxygen, they perform better at altitude, they have fewer symptoms of altitude sickness. And again, he's shown that this isn't just an imaginary thing, they're not just trying harder. They actually have reduced levels of chemicals called prostaglandins in their bodies. And the body produces prostaglandins in response to low oxygen conditions. It's behind many of the symptoms of altitude sickness. So again, there's a biological mechanism. And in all of these cases, what researchers like Benedetti are saying is that we in effect have an inner pharmacy. The brain is producing molecules, things like endorphins, dopamine, prostaglandins, that help to regulate the body's physiology in different environmental conditions. And these chemicals can create symptoms and they can ease symptoms. A lot of the drugs we take, like morphine for example, work because they mimic these natural chemicals. They're piggybacking onto those natural pathways. But through placebos, we can sometimes trigger those pathways directly without the use of drugs. Next slide, please. So what does trigger a placebo effect? This has been quite hard to pin down in trials because it's quite slippery. It changes all the time. The proportion of people who respond to placebo varies between 0 and 100%, depending on the circumstances. The exact same placebo can have positive, negative, or neutral effects depending on what you're told about it. I already mentioned how, for different conditions, placebos can trigger different biological mechanisms. And that doesn't really make sense when you start off with, because there's nothing in a placebo, right? So how could one placebo be different to another? How could nothing be different to nothing? And I think this is behind a lot of the skepticism about placebos, but it's really looking at them all wrong, because there is nothing in a placebo. It's inert by definition. There's nothing in it. What is triggering the placebo effect is your psychological response to that placebo. What does getting that medicine mean to you? And that can differ between people and in different circumstances. One of the main psychological factors that trigger placebo effects is expectation, how you expect your condition to change or improve. And that can in turn depend on lots of other different things, like what you're told about a treatment, whether that treatment has helped you before, whether you're an optimistic person in general. There are even cultural differences. So usually red or pink pills are particularly good at triggering placebo effects for pain, whereas blue pills have a more calming effect. They're better for anxiety or problems with sleep, except among Italian men. And the researchers think that it's because blue is the colour of their national football team. So blue is actually exciting, not relaxing. So that's just to make the point that it's nothing about the actual placebo, it's all about the individual meaning that receiving that treatment has for you. Next slide, please. What can placebos help for? There isn't much evidence that your conscious belief or expectation in a treatment is going to have a significant effect on underlying physical processes of disease, things like immune responses, hormone levels. There is actually another class of situations where fake pills can influence those things. I'm going to talk about that in a second. But in terms of just believing in a treatment, that's not going to shrink a tumour or banish a serious infection. But click again, please. What placebos are really good at is influencing symptoms that we are consciously aware of. Pain, depression, anxiety, fatigue. And it can include sort of quite physical objective things like rashes, swellings, for example, gut problems. So all those things that you're consciously aware of, how you feel, these are the things where placebo responses can be very large. And so although placebos obviously aren't going to completely replace physical treatments, there is a very large range there of conditions and symptoms that we would normally medicate with drugs that we can potentially get at with placebos. Next slide, please. So I'm going to talk in just a second about how we might do that, but I just wanted to quickly talk about a question that for me was the most, when I started researching it was the most interesting question, or it was the biggest question I had about placebos, which was why do they work? Like why would thinking that a certain change is going to happen in your body, make that change happen. It sort of seems to be true, really. And I think it's useful to think about why we experience symptoms in the first place. Things like pain, anxiety, fatigue, they're not there just to make us miserable. Like, they've evolved for a reason. They're warning signs. We are aware of these symptoms to tell us that something's wrong, we're in danger, to encourage us to change our behaviours, to get us away from that danger. So pain is a fairly obvious one. You know, if you've broken your ankle, it's there to warn you not to run or walk on that ankle. Nausea is a warning not to keep eating food that might be poisoned, for example. But I think the really interesting sort of emerging understanding of these symptoms is coming out of placebo research, but a lot of other areas of research as well, is that these symptoms, they don't just arise blindly and inevitably from the physical state of your body. Actually, the brain is constantly calculating, like, what is the appropriate level of that symptom for you to be experiencing, and it can push those symptoms up and down. And obviously the physical state of your body is a really important part of that. Things like infection, injury are going to feed into how much pain you're in, whether you're feeling fatigued, whether you're feeling nauseous. But it's not the only story. Physical signals from your external environment, for example, can feed into it. Things like oxygen levels or temperature. You will feel more fatigued at altitude when oxygen levels are low. You feel more fatigued when it's hot. And then also psychological cues. Your assessment of a threat, essentially, conscious or unconscious, is also feeding into that decision the brain's making about how much trouble you're in, how severe that symptom needs to be, how strong that warning needs to be. So if you are feeling particularly worried or anxious about a certain symptom or condition or injury, if you're just feeling alone or afraid or stressed or under threat, that is going to trigger biological changes in the brain or amplify the relevant symptoms. On the other hand, if you are feeling safe, cared for, in control, if you've received what you believe to be an effective medical treatment, then that's going to do the reverse. That's going to trigger changes that bring the symptoms back down. And for me, that was one of the biggest revelations, I guess, when I was researching the book, to realise that there's not a direct line from the physical state of your body to how you feel. That's important. You always have to listen to symptoms that you have, but we also play a really big role in constructing those symptoms. Our mental state and attitude is playing into that, into pushing those symptoms up and down. So we do have an awful lot of control over how we're feeling. Next slide, please. So should we all be taking placebos? You can buy them online if you want to. These are some that I got on the web. They're in my kitchen cupboard at home. The sort of dogma about placebos has always been, the assumption has always been, that they don't work unless you think you're taking a real medicine. So the argument about them from conventional medics has always been, well, it doesn't really matter about the research on how effective placebos can be, because doctors can't prescribe them unless they lie to patients and tell them that they're getting real medicine, and that would be unethical. So that's kind of been the reason for not trying to harness any of this in medicine. But that's turning out not to be true. Just in the last 5 years or so, there have been quite a few different studies in conditions like irritable bowel syndrome, chronic low back pain, depression, anxiety, ADHD, where showing that honest placebos work as well. So you can take a placebo and you know that you're taking a placebo, and it still works. Those patients do significantly better than the ones who don't get any treatment. And researchers are now kind of scrambling to work out, well, why would that be? But it seems that a lot of it is to do with, we've heard about the difference between the sort of conscious and the unconscious mind so far, and it seems that just the act of being cared for, of receiving a treatment, is probably giving a lot of signals to the unconscious mind that the crisis is over, that it can ease off on those symptoms, even if you know consciously that there's nothing in that treatment. So just having that care is important. There may also be something about so in some of these trials, these are, say, patients with chronic low back pain, a lot of them had tried treatment after treatment, drug after drug after drug, and none of it's working. And then they go into the honest placebo trial, and some of them have really impressive results. And as well as the sugar pills, they're also given a seminar, a bit like what I'm giving for you now, explaining about the role of the brain in pain, about heal. And one of the researchers said to me that she thinks that was empowering for those patients, that it was something different. Instead of being passively having to take pills, they were actually given a role to play, and they were given some hope that their pain could change. So it may be that as well that made a difference. And really, I think the placebo effect is not about fake pills. That's how we think of it. But actually, I think it's much, much bigger than that. The placebo effect is really everything about medicine, about our health, apart from the physical effect of a drug. And so when you think about it in that way, we don't have to take fake pills to trigger placebo effects. There are lots of other ways that we can do that. Next slide, please. Alternative therapies, for example, there are a lot of alternative treatments, things like Reiki, homeopathy, acupuncture, which from a scientific point of view don't really have an active physical ingredient, or not one that makes sense for scientists. Generally, when these treatments are tested against placebo or fake versions of these therapies, there's no difference. And so scientists would generally say, well, then they don't work. There's nothing there for patients. We shouldn't be using them. But that isn't necessarily true. I just want to tell you about one trial in more than 1,000 patients with chronic low back pain, so a very big trial. And it was looking at acupuncture. So one group got real acupuncture, another group got placebo acupuncture, where the needles were put in the wrong places on the body, the needles didn't properly penetrate the skin. And there was no difference between those two groups. And this is often what you see in trials of acupuncture. But this trial was different because there was a third group, and they got conventional treatment, including painkillers. And that group did fairly half as well as either of the groups that got the acupuncture, regardless of whether it was real or fake. So I think that what that's telling you is that alternative treatments, they're not necessarily working in the way that the therapist is saying that they're working. What you did with the needles in this trial made no difference at all. But through the placebo effects, through the effects that they're having on patients' minds, through the hope, through the expectation, through the care, these treatments can still be significantly better in some conditions than the best that conventional medicine has to offer. Next slide, please. And there are some researchers who are trying to study that, to tease out, well, what are the real active ingredients of these therapies? Like, why are they working so well? Why do they trigger such large placebo effects? And they're finding that one of the things is the human aspects of care, the bedside manner, if you like. Things like the length of appointment times, for example, the attitude of a practitioner, whether they're warm and empathic or cold but polite. These things, regardless of what care is actually being prescribed, what the actual treatment is, can have a surprisingly large effect on physical outcomes for patients. So I think it is really, I think that's a message there for the medical system, but also for all of us as individuals. When you're looking for a therapist, when you're looking for care, that bond that you're getting with the practitioner and how you're feeling about the care that you're receiving can be really important as well. Next slide, please. Another way of harnessing these things, the power of the mind, is by developing completely new kinds of therapies. So this is a scene from a virtual reality game called Snow World. You put on goggles and you're sort of immersed in this three-dimensional ice canyon. I got to play it as researchers in Seattle have developed this. And it's a really fun game. You're throwing snowballs at all these different characters, but it was developed to help patients with severe burns who have to go through very painful sessions of wound care where the dead tissue is scrubbed out of their wounds. It's seen as some of the worst pain in medicine. Even at the highest safe doses of painkillers, they're still in a lot of pain. And these researchers have shown in several trials with patients including veterans of Iraq and Afghanistan who've been burned in explosions, that if they play Snow World, play this game during those wound care sessions, then that reduces their pain by up to 50% in addition to the pain relief they get from the drugs. And so I've included that just to say this isn't just about taking the edge off a headache. This is some of the worst pain in medicine, and it's having really significant effects for those patients. Next slide, please. So far I've been talking about symptoms, like how we feel, pain, nausea, fatigue, that kind of thing. So I want to switch now into talking about physiology, the sort of physical processes of disease and whether the mind ever plays a role there. So just to start off with, I would just like you to take a look at these lemons. Imagine just picking up that piece in the front there and taking a big bite. Just sink your teeth in, really visualise sinking your teeth in and just really let that lovely sharp juice just run down your throat. And if you've got a good imagination, and if you've had lemons before, that's important, you might start to feel a sort of tingling feeling at the back of your mouth here. That is your salivary glands switching on. You have clearly had lemons before, and your body has learned the appropriate physiological response. It's producing extra saliva in preparation for that acidic juice. It doesn't matter that you know it's not a real lemon, that happens anyway. And that is something that is not usually thought of as being under conscious control. I couldn't just say to you, oh, could you all just switch on your salivary glands, please? But through using that visualisation, that image, that thought, you can trigger that change to happen. Next slide, please. And actually, there are lots of aspects of our physiology, from heart rate to digestion, that are ultimately controlled by the brain, through a branch of the nervous system called the autonomic nervous system. So you don't need to worry about the details. This is just a diagram showing you the nerves going from the brain to all of these different organ systems in the body. The brain is constantly staying on top of all of these aspects of physiology and regulating them in response to the environment. And that, you're not normally aware of that happening. It's not normally thought of as being under conscious control. But nevertheless, the things that go on in our minds, the things that we see, hear, smell, think, believe, can have a very profound effect. And we've evolved that way. Essentially, it's helping our bodies to stay one step ahead of changes that are about to happen in the environment. Rather than waiting for a physical change to hit us, the body is using that information from the mind to change and adjust our physiology accordingly to prepare for the next thing that might be happening. Next slide, please. So an obvious example is the fight or flight response. If you're feeling afraid or stressed, there's a whole load of physical changes that happen through the body. Obviously your heart rate increases, your blood pressure rises, your pupils dilate, blood's diverted from the gut to the limbs and brain so that you can think and move. It also triggers a branch of the immune system called inflammation, which is the body's first line of defence against infection and injury. And all of this is really important in an emergency, that over evolution, that's saved lives. It enables us to respond in a challenging situation. We're preparing for that infection and injury before it's actually happened. But it can also have very negative effects on health. So next slide, please. So just to give one quick example of sort of a very dramatic immediate effect that the fight or flight response can have is in invasive medical procedures. So there are a lot of procedures nowadays, things like keyhole surgery, biopsies, tumour destruction that happens when we're awake. And you're given local anaesthetics, sedative drugs, but it can still be a very painful, distressing experience if you just imagine being that patient there. And this is usually dealt with drugs, but there was a team at Harvard that decided to take a different approach. Next slide, please. This is the only graph I'm going to show you. So they've done trials on hundreds of patients going through these kinds of procedures, and they asked them, this is their pain and anxiety over time through those procedures. And the top line here, the black dots, that's standard care. So they get sedative drugs on demand through the procedure. And you can see that despite the drugs, pain and anxiety are going up. The longer that procedure goes on, the more distressed those patients are. Now look at the bottom line. Those patients, they got the sedative drugs on demand, but they were also encouraged to use visualisation techniques, things like close your eyes and imagine yourself somewhere you'd rather be, whether that's a beach somewhere or your sofa at home. So they were encouraged to use those kinds of techniques to help them to relax during the procedure. And look at the line. The longer those procedures went on, the more comfortable they were. Pain and anxiety fell. They required only half the amount of drugs that the control group needed. Their procedures went more smoothly, were over more quickly. You can see the line is shorter. And importantly, they had a significantly lower rate of complications during the surgery. Partly because, so these are things like dangerously high or low blood pressure, prolonged lack of oxygen, post-operative bleeding, serious complications of surgery. And partly because they didn't require such a high level of drugs, and partly because the fight or flight response was calmed down, those adverse events were much less likely to happen. And so I wanted to include that because I think that sort of shows that just taking care of patients mental state, it's often seen as a kind of nice luxury. But this shows that it doesn't just make those procedures more pleasant, it actually has a really important effect on the physical outcomes of that surgery. And also this is just something that you can do anytime at the dentist or any kind of procedure that you're finding uncomfortable. This is something that's really easy to do. Next slide, please. Obviously chronic stress, that's what we all hear about. When fight or flight is switched on all the time, that's when you get a lot of wear and tear on the body, and that can really contribute to chronic disease over our lifetimes. So chronic stress increases the risk of heart disease, for example. It can cause gut problems. Chronically high inflammation exacerbates autoimmune disease, makes us more susceptible to infection. It disrupts wound healing. It's been implicated in progression of cancer and even in the rate at which our cells age. So one of the things that I looked at in the book was at all of these different stress management techniques that we hear about. What's the evidence around those? Which ones actually work? And so just very briefly to mention two, next slide please, mindfulness meditation. There are lots of different kinds of meditation obviously, but mindfulness just happens to be one of the best studied in trials. And there are now hundreds of clinical trials showing that an 8-week course of mindfulness meditation does reduce stress, anxiety, as well as physical symptoms like pain and fatigue in healthy volunteers, cancer survivors, people with different chronic conditions. Also, neuroscience studies looking at what happens in people's brains have shown that just an 8-week course of mindfulness meditation changes the physical structure of the brain in a way that is the exact opposite of the way you see the brain changing with chronic stress. So it really does look as if the mindfulness meditation is helping to sort of reshape people's brains in a way that protects them from stress. What's going to be interesting next in terms of research is to look at whether that actually feeds through. So people are feeling better, but is it feeding through into the processes of disease? Is it affecting the immune system, for example? And there are a few studies so far hinting that it does. There are studies, for example, showing that people were less susceptible to winter colds if they did mindfulness meditation. There was another one showing that people responded better to flu vaccination when they also did mindfulness. Another one showing that people with psoriasis responded better to their treatment if they also did mindfulness meditation. But so far those trials are quite few and far between, so you don't have the big body of trials that we have for the symptoms. So it's going to be really interesting to see if those results get replicated and built on over the next few years. Great. Next slide, please. When I was doing the book, the thing that came out to me, the most powerful thing that can protect us against the effects of stress was not a technique or a practice, it was actually social relationships. There have been lots of studies looking at everything from DNA, from gene expression in cells, to studies following the health of hundreds of thousands of people over decades. And they're showing what Charles Raison says here: people who have warm relationships, rich social lives, and who feel like they are embedded in a group don't get sick and they live longer. It's probably the single most powerful behavioural finding in the world. Next slide, please. Right, on something completely different. My last thing that I wanted to tell you about, just because for me it was the most surprising thing that I came across when I was doing the book, has to do with how psychological cues can influence the body's front line in the fight against disease, the immune system. And it all started with an experiment that went wrong, as a lot of interesting things do. A psychologist called Robert Ada, again back in the 1970s, let's go back and see how the stories behind things. He was interested in a phenomenon called learned taste aversion, which you might have experienced. This is where if you eat a food, like prawns, for example, and then you get sick, the next time you have that food, even if you liked it originally, it sort of makes you feel sick again. You can't really face that food. And this is a sort of powerful response that we've evolved, is to discourage you from eating food that's poisoned you in the past. Ada was interested in how long did that learned association last, that learned association between the taste and feeling sick. So he did what a lot of scientists do, did an experiment on animals, on rats. I don't know how relevant that would be really, but this is what he did. Next slide, please. And so he gave the rats water that was sweetened with saccharin, so sweet water, which is a favourite treat for the rats. They will drink more of that than normal water. except that in this experiment he paired it with a drug called cytoxan, which makes the rats feel sick. And so after a few pairings, as he expected, the rats started to refuse to drink the sweetened water when he gave it to them on its own. So no drug, just the sweetened water, because they associated it with the feeling sick, so they refused to drink it. So to find out how long they would remember that association, he force-fed it to them with an eyedropper. And what happened next was that they didn't forget the association. Instead, one by one, the animals fell ill and they died. And it turned out that cytoxan doesn't just make the animals feel sick, it's an immunosuppressant. It suppresses their immune systems. And they didn't get anywhere near enough of that drug in this experiment to be fatal. But what had happened was when he paired the sweetened water with the drug, they didn't just learn to feel sick, they actually learned their immune response to the drug. So later, what the sweet taste on its own was enough to suppress their immune systems enough that they succumbed to fatal infections and they died. So in this case, a neutral psychological cue, the sweet taste was enough to kill them. And researchers have shown that the reverse is true as well. You can actually boost the immune system using this same technique. At the time when Robert Ada did these experiments, this was seen as basically pseudoscience. Scientists were convinced that the brain and the immune system do not talk to each other. They're completely independent. Next slide, please. But we now know that that is not true. There's actually extensive communication going on between the brain and the immune system all the time. It happens through neurotransmitters, through chemicals that are released, and also through nerves. And again, we've evolved this way to help our immune systems respond to threats before they actually hit us. I mentioned fight or flight. It will trigger the inflammation so that you're ready for infection and injury before it happens. Again, with these learned responses, it seems that the body is, like with the lemons, you have a lemon and your body learns the physiological response and it will repeat that the next time you're faced with a lemon. It's just the same with the immune system. When you're in a situation and a certain immune response is required, the body can learn that, and the next time you're in that situation, it will trigger the same immune response. And usually that's helpful for us, and an evolutionary benefit for us in this particular experiment for the rats that went wrong. But I mean, I was just really stunned to find out that psychological cues, things like taste and smell, are influencing our immune system. It's really interesting to think about that happening all the time. Can we do that in medicine, though? Next slide, please. This is Marchant Lasky. He's continuing this work now. He's shown that these learned responses do work in people as well. The sweet taste is too familiar for people. We'd be unlikely to associate that with anything in particular. Next slide, please. So he has developed this green drink. It's a mixture of strawberry milk, lavender oil, and green food colouring. I've tried it, it's disgusting. But it's really distinctive. It looks green, but it tastes purple because of the lavender. It's sweet, oily, bitter, milky, turns your stomach. You've never had anything like it before. You would not forget it. Which is kind of the point. And so he's shown that when you give this to people along with an immunosuppressant drug, then pair that a few times, and the drink on its own will suppress your immune system in the same way. He's shown that in healthy volunteers, in patients with dust mite allergy. He's now doing trials in kidney transplant patients to see if by doing this, then the drink on its own can then give them some of the immunosuppression that they need so that they don't reject the kidney with lower drug doses. And so the hope is that this kind of research could help to reduce drug doses in a whole range of conditions: allergies, autoimmune disease, transplants, even cancer, where some of the drugs are based on modulating the immune system, to help reduce drug doses and then in turn obviously reduce side effects, toxicity, drug tolerance, addiction, cost. And so I just really like that whole area of research because it's just a completely different way of looking at things, and it shows how we don't have to go one way or the other. It doesn't have to be all drugs or all the mind. We can use the two together in an intelligent way to reduce drug doses and get better outcomes. Next slide, please. So just in conclusion, often the mind over body, it's kind of seen as a sort of, I don't know, supernatural thing, sort of mysterious, magical power of the mind. And I don't think that's true. I think it's a completely natural thing. It's just biology. We have evolved for what's going on in our minds to influence our physiology through neurotransmitters and through nerves. It helps our bodies to stay one step ahead of what's happening in the environment. And that means, on the one hand, that the mind is not a miracle cure. It can't do magic. It can't your thoughts can't get the body to make chemicals that it's not capable of making. It can't save us when the body is overwhelmed by cancer or injury. Often you can't just will changes to happen. You can't wish pain away or tell your immune system to do something. But the mind can have very real biological effects on how and why and when the mind is influencing the body. Then we can harness that and we can use that to have very real effects on our health. And that's something that I think we can all do as individuals, just realising that we have that control over what's going on in our bodies. But I also hope that with more research, then that could also end up leading to a system of medicine that treats us not just as physical bodies, but as human beings. Thank you.
Does anyone have one question? One very short question. Yeah, go on then.
Hi. The trials that you looked at all sort of involved placebos, which sort of contain an element of trickery on the mind. And I was wondering whether you thought that we had a physiological memory. You know when you have chewing gum, when you chew, your body thinks that it's preparing itself for food, and your stomach produces more acid. That when you take medicine, whether it's working for you or not, your body starts preparing itself to get better.
So it's always been thought that placebos work through trickery, and as I was saying, actually we're starting to realise that it's not always about trickery, that honest placebos can sometimes work as well. And also a lot of the things, when I was talking about visualisation during surgery, for example, I'm trying to explain that I was trying to not just talk about placebos and trickery. There are lots of other ways that we can use the mind too. But in terms of the learning and the memory, I think that's really interesting, because what I was talking about, the learned immune responses at the end, what I didn't have time to say was that those learned responses aren't just affecting immune responses, they're affecting every aspect of your physiology, your heart rate, your digestion, sexual arousal, tears, every aspect of physiology that the brain controls. It's learning what is required in different situations, and we'll repeat those later on. And so so a lot of placebo effects, the expectation, the sort of conscious expectation is one aspect of it, but yes, you do also have these learned responses. When you take a painkiller, your body has learned the appropriate response to a painkiller, and it will release those endorphins or have that biological response, even if that painkiller is a placebo. And it's interesting that the conscious expectation, that side of placebo effects, not always, but sometimes won't work if you know that it's not a real drug. But these learned responses, like with the lemons, happens anyway. And so there's quite a lot of interest now. For example, you could have a blister pack of painkillers where every other one is a real drug and the ones in between placebos. So it'd be ethical. You would know that that's happened, but you wouldn't necessarily know which ones. And the research is suggesting that they would all work equally well. So you would get the same amount of clinical benefit, but with a lower drug dose. I don't know.
Yeah.